you will learn something new. And without further ado, let me introduce myself. I'm Wojciech. I work as a junior front-end engineer at Kuna's team. I've been working at OLX for about just a tiny bit more than a year. And my area of interest are React, GraphQL. I'm also a huge fan of AWS, and I'm really into Golang. But of course, for today's occasion, I'm putting my front-end developer hat on. So don't fret, I will not be geeking on some kind of backend stuff. And I've been using GraphQL for about a year and a half, maybe just a tiny bit more. But what really started for me, the whole GraphQL craze, if you will, is this application. It's something I wrote as my end of graduation project. It was my first experience with GraphQL on a big project, because this application has like 40K lines of code, which I wrote throughout almost a year. So the main highlight here is that was my first experience, quite a large for me at the time application with GraphQL, with Apollo client. So that's that. And when I came to OLX, during my internship and after that, we were working on something called Spot, which sadly got decommissioned recently, application which match potential candidates with employers. But again, the main highlight here is that it was using GraphQL with Apollo client, and as well, the backend was serverless. That's something that my team is into as well, serverless stuff. And most recently, I've been working on candidates profile. So that's an application on PWA stack, both mobile and desktop version. And we also have, I would say, great success with GraphQL and Apollo. So no issues there. So what connected all these three applications was mainly this tech stack, React, Apollo, and TypeScript. And for our purposes, we'll mainly focus on Apollo client. Of course, we'll dive into GraphQL, but we'll not be getting expert knowledge from me on the GraphQL, because that's not the point of this workshop. The point here is to get you productive and familiar with abstractions that allow you to work as a front-end engineer with GraphQL. And of course, we cannot talk about GraphQL without knowing what GraphQL is. So let's look at the GraphQL, the big picture. So what really is GraphQL? I have this definition that I came up with. GraphQL is a spec that describes a declarative query language that you clients can use to ask an API for the exact data they want. And there is a lot to unpack here. So let's go step by step, highlighting the most important parts. A spec, first of all, GraphQL is not a library. It's not a framework. It's just a specification, a piece of document that some people wrote and some clients decided to adhere to, mainly, of course, popularized by Facebook. The specification itself brings a declarative query language. You'll see that this language is quite simple. It's reminiscent of JSON, and there is literally the syntax is very simple. So we shouldn't have any problems understanding it 5 minutes for our purposes here. And I think what's most appealing as a front-end engineer is that I can ask an API for the exact data I want. Of course, there are constraints because we are not living in a perfect world. You cannot just give me that, right? There are constraints, but it's much more flexible than the model that REST exposes for us, because we can now model our components with state as well as the state that comes from the backend. And these two things can coexist and be really one in some cases. And just to drive the point home, this is just a specification. There is a link here. You can read it. I recommend that you skim through it whenever you go about to deploy something to the production that uses GraphQL. So that's just my advice. And when it comes to transport protocols, we'll be using HTTP. It's a standard JSON, no proto buffers, no binary stuff, nothing like that. And we'll be using POST only for this workshop. You can use GET with GraphQL, maybe for for those who heard that you cannot cache GraphQL with HTTP or something like that, that's completely not true. You can do that. We are doing it inside of our pack, but we will be using post requests only, just for your information. And I've seen a lot of articles on the internet about REST versus GraphQL, which is better, which should I choose for my project, right? GraphQL or REST? So I'm not here to tell you which is better. I just want to give you a metaphor, which I think will help you to think in terms of GraphQL, yes, Ajax, GraphQL versus REST. So think of REST as the menu here. And with one item that you have on the menu, you get one endpoint. And if you order one item on the menu, aka call an endpoint, REST endpoint, you get the whole meal. Yes, you can ignore the payload on the client, but if you order a whole salad, you probably, well, you can maybe in some restaurants ask for different ingredients, but mostly you will get what's listed under that item. And think of GraphQL as an buffet where you can get the whole meal if you put the pieces together on your plate, put the ingredients there, but you can also create your own. Yes, there are constraints. As I said, it's not a magical tool, but it's much more flexible. We'll see that in action just soon in terms of how your data can be structured or asked for from my perspective, from front-end engineers' perspective. And as I said, the GraphQL brings with itself, the specification brings with itself a schema language. So that schema language contains types. So we are dealing with some kind of type system here. And it's not that sophisticated as TypeScript, though TypeScript is really not that sophisticated. There are no generic types, basically. But the types in the schema language describe your GraphQL API. So the contract between you as a front-end engineer and your backend piece. That's very important to understand and know. And I will go as far as I say that if you are familiar with any kind of type system, so be it TypeScript, for example, or maybe you are programming with Golang or Rust, I don't know, you pretty much know how to write GraphQL operation and schema. Well, maybe you are not the master of it, but definitely there's a lot of familiarity with any kind of type system. So given this hypothetical scenario, let's say I want to type a message type in GraphQL and in TypeScript. So in TypeScript, that's how one might do that. A simple type can be an interface, debatable. It's not the TypeScript workshop. And with ID of string and content of string, right? Pretty simple stuff. So the same definition in GraphQL would look as follow. Would have a type of message and ID, this weird ID type, that's just a built-in type. Basically think of it as a string. We have this weird exclamation mark here. We'll talk about it. And then the content string. The difference here is just casing of the letters. So that's side by side. And let's talk about the main difference really. Here, the ID type on the right-hand side is a built-in type. So GraphQL have built-in types. You can also create your own. But that exclamation mark though, well, that exclamation mark just means that the field is required, as in you cannot skip it on the backend and it cannot be null. And the difference is that in TypeScript, we don't have to write that. That's because the fields in TypeScript are required by default. You have to use the Elvis operator or maybe union with null or undefined, or maybe use partial, optional, whatever the type you have to mark the field or the type itself as optional. In GraphQL, the fields themselves are optional by default. Thus, the exclamation mark to mark it as required. And just a tip, you should be marking as many types, of course, to the level of sanity as required, because Otherwise, you'll be dealing with a lot of null checks on the front end, and you don't want that because null checks produce errors. That's very simple. And to get the schema language, to know it better, to understand it, to get a feel for it, we'll go to a place which is called GraphQL Playground, and then really encourage you to follow along, because if you have the application running, you have it running as well. So there, you can think of it as a Swagger for REST API, or Swagger for GraphQL, really. We'll play around with the schema, we'll see what our backend exposes, and then we'll go to exercise to set up the Apollo client. So going to the playground, it's very simple. All you have to do, let me just zoom in. All you have to do is go to localhost on the port 4000/playground. That's it. And you should have this window open. Not this address, this address. So I have two planes here. The left plane, I will be writing some code here, mainly operations, asking my backend for data. And on the right-hand side, I will get the data displayed, right? So I mentioned a schema language. Well, let's look what the schema is. Again, schema is the contract between frontend and the backend. And we've seen this message type that's very similar to TypeScript. We can ignore the input type for now, but let's focus our attention on these two types, because they are quite different than any other, right? They have these weird brackets here, like parameters almost. And yeah, they're just different. So just to make sure you know, in GraphQL, there are three reserved, if you will, type names, and they correspond to different operations. So we have a query type, we have a mutation type, and subscription type. There is no subscription type here because it's for real-time communication with WebSockets, and I just omitted it for simplicity's sake. And let's zoom in on the query type. So the query type. The query type is a special type which fields, so this one and this one, describe the read operation that I, as a front-end engineer, can perform. Basically, ask my backend for data. And as you can see, they also obey the law of types. I know that this field will return me a user. I know that this field will return me an array, that's an exclamation mark, no nulls, either empty or that array will have type message inside or messages. I don't know what messages. Well, let me go to the schema. It's all there. Again, the contract, the notion of contract is very important. So these fields describes the read operation, right? So my backend exposes. And how one might go about performing such operation? And it's very simple. It's very, very simple. So first things you have to ask yourself is, what kind of operation do I want to perform? I want to ask the backend for data, perform a read. Maybe you can think of it as a GET request, but we are not performing GET requests here. Well, I want to perform a query. Query corresponds to a read. Now, what kind of field? Well, user. And then I want from user first name, last name, and let's say ID. And if I click this button, there it is. The data is here. And the data is structured. There will always be a data field, and there may be an errors field here under this bracket, but we don't have errors, so there is no error field. And let's say I don't want the first name and or last name already. I only want the first name. Well, there it is. And this is why the GraphQL is such a great tool, because I'm saving the battery, preserving the payload. Like the payload is really small, and I'm asking really only for what I need. I'm not asking for the whole user here. And the backend is not sending me the whole user. It only sends me the first name of a user. I can also ask for every property there is. So I see that the user has ID, first name, last name, and hobbies, right? So last name, ID, hobbies. Hobbies is an array of strings and can be null, but it will not be, because I basically hard-coded GraphQL there. We will be also changing that. So yeah, I can ask for the whole user, just like in a buffet. I recreated the item on the menu, but I can also create my own by deleting these properties, like here. Okay, so the user is very simple query. It doesn't have any parameters. Let's zoom in on the messages then, because the message has these weird parameters with even default values, as it seems. Again, that's the schema language. Very simple, but let's ask for messages. What kind of operation do I want to perform? Well, query. What kind of field? Messages. And since there are default values here on the message type, on the message query, on the message field, I can omit the parameters, omit the brackets here, and ask for only for the content. And the content will come in. 25 is the limit, delay of 0. Delay is a parameter that I added to artificially delay the request. And if I want to specify parameters, well, all I have to do is just specify them, really. Limit 10, there it is. And I get 10 messages. One message with delay of 1 second. I'm gonna wait 1 second, and there it is, the delay kicks in. And the order of them, so the limit delay, does not matter. That's because we are labeling them, if you can see. Like, I have to explicitly say limit here, or explicitly say delay here. In JavaScript, we don't have that. In JavaScript, you would write 1 and 1000. In GraphQL, I can switch the parameters. So that's pretty good. And it still works the same way. I get the same payload. Again, preserving the data, or maybe only want the latest message or something like that. So that was the query. We'll be working with query extensively. So this is just to give you a feel for the language itself. And now let's go to the mutation type. Mutation, as maybe the name might suggest, will be writing something. Sometimes we as a front-end engineers are a bit scared of mutations, right? Because on the front end, it's not a good thing to have to mutate something usually. But here, the mutation type, the fields of mutation type describe the write operations. So I'm going to write something. Basically perform a post request. You can think of it as a post request. In actuality, we are performing a post request here, but that's just a loose connection, right? So just to give you an idea, it's not really like I'm performing a query, so I'm performing a get. No. I'm performing a post. So let's say I want to write a message. Well, what kind of operation? Mutation, because I want to write. What kind of field? Oh, message. And I have to specify the parameter here because it's required noted by this exclamation mark here. And this is where the input type comes in. So the input type is like a container for parameters, really. So here I created a container, an input type with one parameter field, content, string. I could have also done this with the messages, but I didn't because I wanted to show you that there are two ways you can mix and match even. I could have packed delay to an input type, for example. I don't know why would I do that, but you could. So the input types are used as containers for parameters. That's it. That's the simplest explanation. So input is a container, like an object in JavaScript, really. Content, and for example, GraphQL, right? And what do I want to get back? I know that I will get a message noted by the type. Again, the contract is very important. So I can ask for content and create a dot, for example. And I've written to the database, the message GraphQL. Now, the update user is very similar. We'll also be working with that. So what kind of operation? Mutation. What kind of field? Update user. Parameter, I have to specify it, noted by the exclamation mark here. So input. And now this container has, I think, 3 fields. Yes, there it is. 3 fields. So I can specify all of them. There is no exclamation mark near them, so I can omit some of them, or I can specify all of them. For example, I only want to change, or maybe let's query for a user, so we'll see the difference. Query user, first name, oh, let me, first name. Okay, so first name is user first name, not quite well, let's change it to my name, so Wojciech. So first name, Wojciech. And first name, last name. I'm getting first name, last name. Why? Because, well, I want to update a user, for example. I want to refresh my UI on the change. And I know I will get a user back annotated by this exclamation mark. So there it is, Wojciech. And for now, this intuition that I hopefully built for you here should suffice to be just productive to maybe fifth exercise. So let me just check. Yeah, we can start working on our application. So what we'll do now is we'll wire up Apollo client, so the library that will interact with our backend, because the playground here does a lot of work for us. It's the separate application, really. I think it uses React and some kind of GraphQL client as well. So it enables me to write these queries effortlessly. We'll be doing the same with Apollo client. And of course, there are other bells and whistles that Apollo client exposes. So if you go to your local host on the port 3000, you will see this application. It contains the list of exercises we'll be going through. There's an exercise tab and a final version tab. So the idea here is that you follow me along and code along. There's also a description here. If you ever get lost, you can also ask me a question. Don't worry, you will not. I've trained this workshop a lot of times. There shouldn't be any problem with interrupting me. So the idea here is you have some context here, and then we'll go through the exercises, also the extra, thank you, also the extra credit ones. And yeah, just let me take a drink. And we'll start from the very basic stuff, don't worry. And if you ever get lost, need help, I will be going very slowly. So please notify me as soon as possible, as soon as you are lost. So I hope that the font looks good. So Apollo client. Well, there are many clients available for GraphQL. And why I'm teaching Apollo client here, that's because I think it's the best one, really, in my opinion, of course. Why? Because it has a whole company behind it. It's very popular, battle tested, really, and I'm also familiar with it, so I decided to go with it. So what we'll do now is create basic building blocks that will connect together so that we can perform GraphQL operations, just like we did in the playground. Now, of course, we'll do that inside this the code. So the Apollo client itself, let me just write it here. All the imports already should be included. So you shouldn't have to import anything. So Apollo client consists of two things at the most basic level. Actually, one thing, actually. Only a cache is required. So the cache, well, it's a cache, right? There are many implementations. Yeah. Yeah, exactly. Yeah. The URL queue is a bit lighter. Yeah. Because Apollo contains a lot of stuff and does a lot of stuff for you. So the cache is, well, just a cache. We'll be using in-memory cache. In-memory cache for now. There are other implementations. There's probably the cache that for the built-in database that is built into the browsers, IndexedDB. Oh, that's the name I was looking for. But we'll be using in-memory cache as is the most popular one. And the cache is really tricky. It can be really tricky if you don't know what you're doing. So I hopefully I'll be able to explain it enough so you don't have problems I had before. So the cache is required. But this in itself, the client here will not allow us to do any kind of request. The Apollo client is built on the series of middlewares called links. And one of these links that actually makes requests is something called HTTP link. So we can delete the cache, HTTP link. So new HTTP link. It takes an URI, and let me get the URI from the backend URI. We can also specify headers here. For example, authorization. That's a very basic authorization, way of authorizing, because this is a static value. This will be resolved whenever you import this file. That's usually not what you want. Oh, we'll see how to implement authorization later on. And let's paste the link here. Okay, so now we have our client. And you may be familiar with the notion of providers. Well, I hope you are, because the notion of providers and React context dominated really the React ecosystem for, I think, for previous year or two. So to make the client available to every place in our app, really, Apollo exposes something that is called Apollo provider. It creates a context, and then things that you import from Apollo client get pulled from the context that you defined at the root of your application, for example. And we'll do the same. So we'll create the Apollo client provider. Yes. Just let me return stuff. Okay, and it takes a client, which is of our client, and it needs children. We can write application here, doesn't matter. So, and the application should be visible. Yeah, there it is. We have application. So this is how one might really wire up the most basic setup of Apollo client. But this is kind of messy. Everything here, we are initializing the client, and let's say this is our application. You usually have more providers in your application. Maybe you have more imports. You want to separate concerns usually. And this is where the notion of provider components come in. You are probably familiar with those if you ever written context hooks, basically. So what we'll do is basically wrap the whole setup here, this whole logic, to a separate file. Let's imagine I'm creating a separate file here, and this will be app file, right? And we don't want this mess in our application. We want to control the setting up of Apollo client in a different file to, to make sure it stays consistent. So we'll create an component which is named the same as the Apollo provider. Provider, right? And that function needs children, because we want to render an app under it. So children, React Node, children, props. And why I'm using React Node here, maybe if you are not familiar with TypeScript. So there are different types that you can type the children. One of them like JSX element, I think, and there are others. So React Node is the type which allows for every valid JSX child. So you can string, null, array, component itself, right? So an object. That's why I'm using React Node. I don't want to be that strict. Usually the React Node is the best practice to use, in my opinion, at least. And now we can return here, Apollo client provider, pass the children, and client here, client, remove all this mess from our application, and we can wrap it with Apollo provider here. Oops, too much. There it is. Yes, yes, exactly. Props with children. Huh, interesting. Okay, so we created the provider component. Now our application, see, there is no mention of Apollo. Well, the component is named Apollo, but there is no client, nothing like that. And at this stage, you might think we can jump to the next exercise, but there is one test I want to write. And there's a story behind this test. So I was debugging some stuff and I changed the URI here to a local endpoint. As you can imagine, I shouldn't push this to the production. Well, to my surprise, it went through the code review and I pushed something like this. Or whatever the port is, to production. That's not good. I want to write a test, simple test. Usually maybe this will be covered by your end-to-end test, but we didn't at that stage. A simple test that will make sure that the HTTP client actually has this value. Of course, the URI might depend on some kind of environment. It may depend on some feature flag. You might imagine that the test would be a bit more complex, but I want to just, warm us up because we will be writing some tests later on. So I exported the HTTP link. I have everything prepared in the tests folder. That's 01 test.sx. And all I want to check really, again, imagine that this test is more complex. So all I want to check is that HTTP link. Oh, that's the wrong import. Let me import it manually. Exercise, that's 01. Yes. The HTTP link, options, URI, to be get. Yeah, and just let me call it. Okay, and that's the test I want to write. That's our first test. And I'm going to copy relative path here and just use my terminal, yarn test, copy the path. The test should hopefully pass. And now we are not pushing broken code to production if we don't have any end-to-end test. And yeah, we don't have to endure 2 hours of broken production and then all the nasty stuff that comes after that. Okay, so we were able to set up the Apollo client. And now let's try to actually perform some operations. And this will be eerily similar to what you saw on what I did in the playground. We'll perform some queries. We'll use hooks because Apollo exposes a lot of things. It exposes higher the components which can fetch data. It exposes hooks which can fetch data. And since, well, we are basically almost at React 17 right now, everyone uses hooks, so why shouldn't we? So the way you write queries in React using Apollo client, but that's a client agnostic way of writing queries. Is, well, you have to define a variable. I'm using very explicit names here. That is because I want us to not get confused which exercise we are doing or something like that. And there is this weird GQL stuff. That is a feature of JavaScript. I know, maybe I think not a lot of people know about this. So this is something called a tag function. You probably never use this, or almost never, really. I use it maybe like 2 times in my life. So the deal here is that you can write a function. It will take some params. I don't even not sure of the syntax, but you can call it like this. And this is a valid JavaScript call. See, I called the function, and TypeScript even tells me that it returns void and the params are array any. So basically that GQL is a function. That function will parse our query to something that is called an abstract syntax tree. This is the notion of abstract syntax tree is, well, I don't know if we should know about it, really. I should tell you, because just know that it parses the query in such a way that it can be validated, again, because we are using the type system. Remember, the schema language has a type system, and optimizes this just a little bit, and then allows us to do more things that we'll do later on. So this is just a function. Here we'll write our query. And the query will be written in the same way, really the same way as we did in the playground. Well, it will change later on as we are adding more stuff and our queries are getting more difficult. But all we have to do here is, well, ask for a user, right? Because if you go to this exercise 2, and it asks us for, oh, actually get messages. Okay, so I was wrong. Good thing I checked. So it asks us to get messages, and how we did that in the playground. Just to illustrate, we ask ourselves what kind of operation? Well, query, right? What kind of field? Messages. And let's say content and ID. ID for the key, you know, when you are rendering list. Okay, so we get messages here. So check this out. We can do just copy and paste here. Oh, I pasted in the wrong window completely. Okay. So, and this is a valid query. This is a query which will be parsed by this function. And with that, we can make our first request with Apollo. So there's a hint to use query hook. So we'll do that, use query. And we are going to pass this query, right? Exercise to query. And the query itself returns a lot of stuff which can be helpful, but mainly data, loading, and error. And no longer you have to manipulate state manually with, you know, const is loading, set is loading, or whatever. You might have composite state with an object here, right? State, set state. And that's cumbersome. Apollo does that for you. And there's also a lot more stuff here, like refetch and all that stuff, all the other stuff. Just consult the documentation because there's a lot of props here. Okay, and now, well, what we want to do? We want to check for an error. So if error, return will be the error checking will be rather simple for us, just for simplicity's sake. Let's write an error. If loading, well, return loading. And now, the results should be written to chat messages list, blah, blah, blah. Okay, so return chat messages list. Already, everything is already imported. I hope that you don't have to import anything manually. And the data or messages, yes. So the messages, well, the data is any here. That's kind of bad, right? We are using TypeScript for type checking, type safety, and here it's any, not good. So we have two escape hatches here. We can specify types, passing a type parameter. That's because the use query is a generic type function, and it cannot infer the type from the query here, because how would that work? Like, it just a parsed an object comes out of the, it is a document node. So how would I do that, right? You have to specify the type manually, or you can generate the types. We'll be generating the types in, I think, exercise 4. So the type is, well, messages, and then it's an array of messages, right? You can write it like this. I have no preferences. I usually go for the first way that I've written, but yeah, it's equivalent. Okay, so we can specify data. Now it says that it's an array of messages or undefined. Well, undefined, since the data will be undefined when it's loading. So we can write data and messages, but see this optional chaining stuff. I'm not a fan. If you are, then of course, that's good for you. But it also complains that messages can be undefined. So we could also write it like this. Now, a lot of noise here. So what I usually do is perform a simple null check here. And this is to allow TypeScript to infer from this condition that the data here, not data grid, data, is a non-nullable type now. It is of type message array. And why do I do that? Well, TypeScript has no way of knowing that the data is correlated in any shape or form to this loading prop, right? So it doesn't know that if this, yeah, you can ignore. if this loading prop is false, then the data has to be there. There is no way for TypeScript to know that. That's why I'm performing this simple null check. You can also do it like this, but again, there's a lot of noise. This is probably a preference thing. You do you. So this is how we really perform a query. This is how we go from prototyping here and getting to know our contract to actually getting the data from the backend. And if you go to the exercise page, there will be a messages. TypeScript police. Okay, so we've written a simple query. Let's write a simple test for it, because testing is really, really important. You cannot say that you know a technology unless you know how to write tests for it. And the test is 02 test TSX. And we'll write a very simple message, a very simple test, which basically checks if the message are fetched. But there will be some crucial concepts, which we'll be using throughout the workshop. So what we'll be doing is writing a test using React testing library. I think this is an industry standard thing. So hopefully you know the basics. And if you don't, I think it's declarative enough that it really, the queries resemble Cypress. So you shouldn't have any problems really. Like, you may be unsure, but if you see get by text, well, that means get the thing from the DOM by text, right? So let's start. What do we do here? Well, the act of calling this function, not going into React details because that's not the workshop for this. Simplifying things, of course, is act of rendering. So we have to render something, right? Well, let's render the exercise 2. It's already imported. And with that, let's try to run our test and see what happens. What will happen is you see a wall of red text. So here we have a problem that the use query cannot find the client. And remember, in exercise 1, I'm going to switch there, we created this provider, right? But here we are testing our component in isolation, as we should. Because this component shouldn't be concerned with wrapping itself with the Apollo provider that we created. So one way to do this is to recreate the client, right? Do it the same thing as we did in the exercise 1. You could also import your provider here and the provider component that you created in exercise 1. But there's a better way. There's actually 2 ways. I'm going to show one because the other one is a bit more advanced. Apollo exposes something that is called a mocked provider. And as the name suggests, it is a Apollo provider that we can use to mock the data. And you could mock the use query itself. I'm not a fan of such a low-level mocking. I want to use the tools the library exposes. So here we can specify something that is called a mocks. And this array contains stuff that we will be using to mock the request. Instead of workarounds with is there a normal DI container? Well, you have to, well, we had to write like 8 lines of code. I know it can be a bit frustrating to write the container ourselves, but you only do it once. So I think that the Apollo team decided not to include it. It's also a thing that I advocate really. I'm not sure if it's even listed in the documentation that you should do such a thing as create the container yourself, because, you know, but I think it's separates concerns. So I don't know if there's a the container for this process already provided. So we have the mocked provider here. Okay, and the mocks. So the mocks have specific shape, and the shape of the mocks is very important. So let's write query mock of type mocked response. There are two fields that we have to satisfy. Actually one, but two in our case. The request and result, not response, result. This is what got me when I was writing JavaScript. So the request, we have to specify the query. For which operation do we want to mock? In our case, it's, let me just close this. It's the query here. For this operation, we want to mock for this operation. So we can import it from exercise 2 to 1, exercise 2, from exercise 2 messages query. Okay, so that's the query you want to mock, right? Exercise 2 messages query. And the result. As I said, the result is structured. There will always be a data field, just like we've seen here. Oh no, this one. There will always be a data field, and there may be an error field down there. So we have to return the same structure. So data and messages, an array of messages. Let's say we want to return 1, ID 1, and content of first message. And the message here that I specified has to be the same thing that I'm pulling here. Otherwise, the mock will not work and you will end up with a warning. And it will be not like the debugging, the mocks, wrong mocks, is not fun. So we can specify the query mock. Okay, and what we want to do is to make sure that the message is visible. So we want to make sure that we wait for the loading to disappear and that the message list contains our message. So I wait for element to be removed. It takes a callback, and then we screen get by text. Pretty simple, loading. So we are waiting for the loading to be removed, the text, and then we can assert that there is a first message at our screen. Well, expect screen get by text. You can also, I'm going to be using a regex notation here. You can also go like this, first message. But I find it faster to just write something like this. That's completely up to you. First message to be in the document, right? And hopefully, when I run this test, it should pass. And we'll make it better just in a second. Okay, now, nice. But, well, I could also render a first message here, right? Like someone could break the test or basically pass the test by implementing it here, right? Data, messages, 0, content, for example. That's not good. Well, we want to make sure that at least that the message is encapsulated with correct tag, for example, a list element. And this is where the get by raw queries come in. Well, they force you to implement accessible application or more accessible than usually. Sadly, the accessibility is often overlooked. Well, that's pretty bad, but well, let's improve this test by getting more confidence. Expect screen get by role list item to be in the document. So we have a list item, and we can also expect basically uncomment this. You can also improve it that that list item contains the text, but for the purpose here, I think this should suffice. Okay. So it passes. Great. Now, we've seen that the messages takes parameters, right? We were able to write them limit 10, for example, or delay of 1 second. And here we are not doing it. We are not passing anything. Well, we can try to pass something, but how we would do that? We can do it like here, just like we did in our GraphQL playground. But this is a static value, right? We are not doing it dynamically. Let's say you have a component that takes the limit as a prop, limit props, and you want to somehow pass it to the query definition. Well, you could do something like this, where you do it like this with tag literal. Oh, that is a way, but I would not recommend doing that. There is a much better way. It also has to do with caching, but we'll touch on it later. So to pass the variables to the queries, we are going to use something that is called query variables. These are parameters. See this tab, query variables? This is what we are going to use. So query variables are just placeholders that you defined and then populate inside of the query here. And then these get replaced and passed to the parameters. So to use query variables, we have to name our query, because at the moment, this query here, the read operation, is anonymous. It's just like if you were to write a function in JavaScript without the name here. There's no name, or maybe you wrote an arrow function. This is anonymous function. That's not good. It will not show up on the stack. Well, it will show up on the stack trace, but the name will be either undefined or no name, something like that. I'm not sure. Either way, you want to name your queries. And I usually name my queries by the name of the variable without the query string here, because it's I will be replicating query here. So exercise 2 messages, and the variables have a dollar syntax. So limit, and I have to pass the right type. This is where this GQL comes in. It parses the query and validates the types. So here, it will know that the limit that I pass basically here will have to be an int, and int translates to a TypeScript number. And I could name it whatever I want, right? And I can pass it here, whatever I want, but usually you will get with limit and limit. You'll name it the same as the parameter, basically. Okay, so we have the limit, and to pass variables, you use the second property on the query. So now you specify the query, then the variables. And it's not good. Like, look, it's record, undefined. It's not typed. Again, we'll look into that. But for now, there's a second argument, which we can use to type our variables. And we know that the variable will be limit of type number. And now TypeScript screams at us. That's pretty good, because we can specify the limit, which comes from the props. And now, if you go to your, oh, right, always forget. Because we are taking the prop here, and it's rendering in usage. We have to specify the limit in the usage. Let's say 10. And now if you go to your application, you'll see 10 messages. We can specify one to be more visible that we are actually passing the property. Okay, one message, right? Pretty simple. So what happens with our test? Now, if you run our test, I can specify the limit here. Well, if you are mocking low-level stuff like use query, your test would probably pass, because you probably would be ignoring messages or not doing, like, you know, if variables are not what you expect inside the mock, then you are going to throw, for example. I don't believe that you remember to do such things. And rightfully, now our test will fail. And again, this weird block of errors. But this is the most important message. This is where you spend 80% of your time if you are starting out with testing GraphQL Apollo client using this way. This is the documented way. So this is the way to go. it said that no more mocked responses for query. Well, the query is here, but look, the variables, well, we are not passing variables here, right? So the mocks have to be the same, the exact same thing that just like we pass it here. So if I pass any kind of variables, the mock has to correspond for that. And if I pass 1 here, I have to specify that the variables, well, I have to specify a comma here, variables will be of limit 1. I don't write int, I don't write limit, nothing like this, exact 1. Exactly the thing that you are passing to variables. The same goes, for example, for the return data, but I just ran this test. Okay. And it passed. So the mocks has to be exact. And let me remove the content here. Now, in our query, we are asking for content, but in our mock, we are not returning content. Again, if you are mocking, you may overlook this scenario. If you are mocking low-level APIs like use query, of course. But the mocked provider is ruthless, and yeah, it just, or maybe just let's just skip the ID on. That would be a better case, because then the element may be displayed or an error may be displayed. Let's see. Either way, it will fail. I think it's failing because the error is showing, probably. But just know that you have to specify your mocks exactly as your queries, and the variables have to be also exact. And that's something that you will debug a lot, especially if you are starting out with GraphQL. So with that, I think we are ready for like 10 minutes break. And then we'll continue with mutations and then code generation, all that good stuff. So I'm going to stop sharing my screen for a second and pop up the timer for 10 minutes. If you have any kind of questions, then you can also leave them at the chat. Just give me a sec. Okay, now we should be okay. But other than that, I recommend that you grab some drink, stretch, I don't know, whatever you see fit,